Okay, good morning to all. Well, let's start if you like. This slide was where we left off yesterday. We were going on discussing software testing, and this slide was specifically about why do we need to perform systematic testing. Um, Well, because according to several empirical studies, a professionally produced commercial software system contains 3 to 30 defects per kilo lines of per 1,000 lines of code. The average debugging effort per defect is 12 hours of working time. So this is an enormous time per defect. And further, maintenance is about half of software development costs, mostly in the effort of removing errors. So that's why we need to perform systematic testing. Because as small as possible, facing as small as possible faults and errors in the software product is better for us, and that we can effectively we can effectively eliminate by performing systematic testing. Okay, well, let's now see an example about how we should prefer, or what kind of test cases we should prepare. Let's get familiar first with the example problem. The program. This is, of course, a very simple example, and you will see even in this simple example how many test cases can be or should be used and prepared. The program reads 3 integer values. These 3 values are interpreted as representing the lengths of the sides of a triangle. The program prints a message that states whether the triangle is scalene, isosceles, or equilateral. So scalene means çeşitkenar, isosceles means ikizkenar, and equilateral means eşkenar. Write test cases, that is specific input values that you feel would adequately test this program. So this is our task. We will prepare test cases that we believe will sufficiently test this program. In a valid triangle, no side may have a length of 0 or less, and each side must be shorter than the sum of all sides divided by 2. Otherwise, that wouldn't be a triangle, if you know, as you know. Okay, in equilateral triangle, all sides are of equal length. Isosceles triangle, 2 sides are of equal length, and scalene triangle have sides each of a different length. Now let's continue with the example. In mathematics, the number of integer values are infinite. However, computers have finite space, which limits the number of values that can be processed. Let us assume that our triangle program is running in a tiny computer with 10,000 as the largest integer value. Then there are 10 to the 4, that would be 10,000, times 10 to the 4 times 10 to the 4, which is equal to 10 to the power of 12 possible length combinations of triangle sides, including the invalid ones. Even in such a small range, even in a small computer, you see how fast the number of test cases we have to perform testing grows. Suppose that you are a very fast tester running and checking 1,000 tests per second, 24 hours per day, and 365 days per year. So you perform testing, assume that you perform testing uninterruptedly, and your speed of testing is 1,000 per second. Then the exhaustive testing effort, testing each possible length combination, that is, would take over 31.7 years. So this small example should give you an idea about how hard it is, even in such a small example, to perform exhaustive testing. So it is impossible to test all cases in any problem. Okay. Now, if this is the case, if there is so many, if there are too many test cases, if we want to perform an exhaustive testing, then how should we compile the tests that would adequately test the given problem at hand? Well, this is an example. This is an example. We will talk about the examples in the coming chapters in more detail, but this should give you an idea about how tests are prepared. And this should give you a first idea, let's say, a brief idea about how tests should get prepared. Okay, well, for the scalene triangles, for example, we prepared 5, 3, 4. The inputs should be 5, 3, 4, for example. For an isosceles triangle, 3, 3, 4, and for an equilateral, 3, 3, 3. Now, let's look at the fourth test case. This is another isosceles one, 50, 50, 25. Well, why do we perform two different isosceles triangle? Well, because the fourth one, there is a difference between the second one and the fourth one, and this isosceles triangle, this test case for the isosceles triangles is a boundary test case, because we have 50, 50, and 25. I'm sorry. This is okay. This is a combination of a boundary test case. For example, well, let's no. This is simply another test case for the isosceles triangle, and fifth and sixth test cases are the combinations of the fourth test case. Okay, the seventh one is an invalid one. Why? Because the third edge length is 0. We have other invalid test cases here with negative lengths, or with one side too long, and the combination of these the ninth test case, which are also, of course, invalid, and another one that is even not equal, at which the one edge length is even larger than the sum of the other two edge lengths. And there are combinations of the 12 test case. Here we have another invalid one. This is again the combination of the 12 test case and 16 and 17. So they're all invalid and combinations of the 12th one. Uh, 18 is another invalid test case. 19 and 20 are other invalid test cases. The 21 with different characters as edge lengths added to the set of test cases. Here we have missing edge lengths in the 22nd, 23rd, and 24th example. So um, as you see, we have several things here we can make remarks about, which are we have here uh, one for each uh, one for each triangle. Here we have another remark is we perform permutations of test cases, and another important remark is that we have much more test cases in the invalid side than we do in the valid side. So we use a lot of test cases to perform. I'm sorry to check the behavior of the program about if the invalid if the input is invalid. What happens? How the program behaves if there's an input if there's an invalid input given to the program. Okay. Well, let's check out the remarks about the example at this slide. Most test cases represent invalid inputs. Each valid triangle type is tested at least once. Permutations are used to check that the order of invalid input values do not affect the result. Boundary input values are used. Length of exactly 0, length of exactly the sum of all sides divided by 2, etc. Input values of wrong type, non-integers, are used. And finally, final remark is, the sixth remark is, that the number of test cases is rather small with respect to the number of all possible inputs. So you may look at these test cases again and see whether you can add other test cases that would more adequately test the simple example according to your beliefs. Okay, here I remind you again of the V model development to remind you of the importance of the concept of validation and verification, that it comprises the entirety of the software process. You will see again towards the end of this chapter that while we perform, while we achieve the test plans, we make use of the specification documents, design documents, etc. And then using these documents, that is the test plans, we perform the testing. And it works in this V-shaped order. Now, we will talk about different types of testing. This is we start with the module or unit testing, and then we go all the way through acceptance testing. Here we have the unit testing. This is the testing of the smallest pieces of code. Uh, Here, each independent unit is tested separately. The level, the level of the testing is the source code, and this may come a little different to you, but you will see in the next slides that what the level is, and you will then say, okay. Uh, and the need for the simulate this is the need for the simulated execution environment. Here we need a simulated execution environment for performing module testing. Okay. About the integration testing, what do we test here? We test modules grouped into subsystems. So here we call the testing the way of the testing, Big Bang testing, and uh, Big Bang testing, and all the modules tested as a whole. And here in integration testing, we test the okay. We test the interface of the modules to the entire system, to its let's say, to the other modules that they're connected to. Okay, so here we rather test the connections of modules to each other. Here we use incremental approaches while we test the modules into subsystems. Well, the level is stubs and drivers. That means we use other testing tools that are uh, there are tools, that are software tools that check out to see whether the input modules work correctly and their interface work correctly. So as you see, here we have uh, as you see here we have as level interfaces between modules. Okay, that is, here by interface we mean the argument list of the modules that connect a module to others. Okay, now we're at the level of system testing. Here, the whole system is tested, including hardware, databases, sensors, etc. The target is non-functional requirements, the system properties here. Here, while we test the whole system, we actually test the non-functional requirements. That is, we test the system properties, whether they need as performance, capacity, fault tolerance, security, configuration. From these viewpoints, we check whether the software product meets the user needs. And here the level is the external interface. By external interface, we mean we test the system at the user interface level. From the user interface, we test the software product to see whether the non-functional requirements are met. Okay, now let's look at the special types of testing. There are a load of them. Well, we will see several. We will talk about several, and then we will continue with the rest of the chapter. For example, volume testing, load stress testing, security testing, performance testing, configuration testing with different ways of configuring the software product, installability testing, whether it is installed easily and correctly, recovery testing, whether it recovers from some fault, reliability and availability testing, how reliable it is, how available it is, maintainability testing, and protocol conformance testing, etc. So there are many types of testing. Let's check several examples, several samples of these testings. For example, volume testing is a non-functional test. What does it test? It tests um, the software product with some size of inputs. It refers to testing a software application with a certain amount of data. For example, the database size is one important concept. The volume testing performs testing on a software product. The size of an interface file, for example, that is subject of volume testing. Let's see two examples of volume testing. What do we test when we perform volume testing? Volume testing, an application with a specific database size, for example. We expand the database of the software product to a specific size and then test the application's performance on it. How? We want to see how the software product performs given a specific size of database. Or suppose a requirement for the application is to interact with an interface file. It could be any file such as a .dat file or .xml file, etc. This interaction could be reading and or writing on or to or from the file. You will create a sample file of the size you want, the sample interface file of the size you want, and then test the application's functionality with that file in order to test the performance. Here again, you test the performance of the product here for a given size of database and here for a given size of interface file. So this is volume testing. It tests your software product for a given size of input files. That could be a database file or an interface file. So this is so much for volume testing. Please, if you have any questions, use the chat panel so that I can see you. And if you like, I can unmute you too so that you can ask your questions. Please let me know that you have a question from the chat panel at least. Okay, security testing. Security testing, this third testing, is another type of special testing that determines that a software product protects data and maintains functionality as intended. Here in security testing, we are concerned about six basic concepts. These six basic concepts should be covered in the security testing. These are confidentiality, integrity, authentication, authorization, availability, and non-repudiation. So these six concepts should be tested in a security test. What is confidentiality? Okay, what should a security test check in the software product when it tests the confidentiality of the software product? It should check against the protection. I'm sorry, it should check the protection against disclosure of information to unauthorized parties. So security testing gives an effort to see whether the software is well protected against disclosure, against showing information to unauthorized parties. About integrity, integrity is a measure that allows the receiver to determine that information provided by the system is correct. So another task of security testing is to make sure that the measure that allows the receiver of the information to determine that this information provided by the system is correct. Okay, so security testing makes sure that the measure, this measure, is good enough for the user of the system. Um, Authentication is another concept. It is confirmation identity of a person tracing origins of an artifact or data piece or information piece, or ensuring that a product is what its packaging claims it is, or making sure a computer program is a trusted one. Okay, so authentication is like confirming the identity of a person or tracing origins of an artifact. That would be a data piece or some file, anything that the system provides the user with. And it should ensure that a product is what its packaging claims it is. So authentication should persuade or make the user believe that what product the user is receiving from the computer, it is actually what it originally should be. Uh, Authorization is another concept that should be covered by the security testing. It is determining that a requester is allowed to receive a service or perform an operation. Okay, so authorization is an important thing because uh, any one may request to receive something from a software product, but if this feature of the product works correctly, then the software should correctly determine whether this requested is allowed to receive that information or service. Availability, you know this uh, from our previous discussions about the non-functional requirements in critical systems. This is assuring that relevant service will be ready for use when expected. So this is also subject. This is also a subject of the security testing. Another concept that the security testing should check out, examine, is non-repudiation. Non-repudiation assures that transferred some message transferred is sent and received by the parties claiming to have sent and received it. So, non-repudiation, the concept is to make sure, for the system to make sure that the parties that send and receive the message are the actual transmitters and receivers. Okay, so much about the security testing. Do you have any questions about the security testing? I want to see from the chat panel if you have any questions. Okay. Well, I pass to the next slide then. Performance testing is another special test type. It determines how a system performs in terms of responsiveness and stability under a particular workload. This is also uh, an interesting test type. This also investigates, measures, and validates or verifies other system properties such as scalability, reliability, and resource use. As you may remember, scalability, for example, is another system property that that questions, that queries whether the system uh, whether the system performs as expected under high workloads when a high number of demands is on the line from the system. Okay, so performance testing actually assesses how the system performs under a particular workload, and usually a high amount of workload. Okay, acceptance testing is another testing type. Well, we have talked about the special test types between or after the system testing, because, well, system testing, as we said, system testing is the test of non-functional requirements. So, given that these special types of testing are usually performed during or together with the system testing. The next type of testing after the system passes these tests, is the acceptance testing. And acceptance testing is the final testing before the delivery of the software product to the customer. So acceptance testing is usually performed on the customer side with the user involvement. Okay, so we have different versions of this acceptance testing. You may well heard of these alpha beta type testings. These testings are performed with the user involvement. Here, actual needs of the customer are tested. Usability testing is performed at the user interface. Development team in the development environment. Here, well, system testing is performed in the development environment, and standard general usability errors are found out here. But during the acceptance testing, real user representatives are in laboratory environment, and in acceptance testing, test-specific usability problems are checked. Real tasks, focal out, taping, post-analysis by experts. These are all concepts of the acceptance testing. Okay. Well, let's look at the two types of testing from a important viewpoint. Well, black box testing and white box testing. Black box testing is the so-called functional testing. This testing type checks the functionality of the software product, and white box testing checks the structure of the software. It uses the structure of the software product, and black box testing tests the software product from a functionality viewpoint. Okay. In the black box testing, in the black box testing, internal details of modules or subsystems are hidden and cannot be studied from outside. So that means the source code is invisible to the testing team. Testing team looks at the specification document, requirement specification document, and the team tests the software product from a functionality viewpoint using this or taken as reference the requirement specification document. So then that means the source code is invisible. We don't, in the black box testing, we assume that the source code is invisible. We don't use the source code. We don't make a structural testing here. We perform a functional testing. We test the functionality of the software product. It concentrates on the interfaces of modules and subsystems. For example, user interface. Okay. Externally observable functionality is tested, and input-output behavior is tested in the black box testing. It is based on input classification. Okay, so that means input classification means we classify what inputs we can feed the system with, what inputs we can present to the system. We classify this set of inputs and then perform the black box testing, taking samples from each of these classes and checking out the functionality using these test inputs. All right, so black box testing is based on the classification of input. Especially, this black box testing is especially suitable for integration system. Black box testing is especially fit for integration system and acceptance testing. So these are, black box testing that, in other words expressed, black box testing is less suitable for module testing, for unit testing. Why is that? Because, again, black box testing is a functional testing. Modules by themselves or units by themselves don't usually perform or fulfill well-defined tasks. Of course, they fulfill some jobs, but these are only a part of a meaningful task in software products. And this is one reason why black box testing is less suitable for unit testing or module testing, but rather suitable for integration system and acceptance testing. And the second reason is that applying white box testing, that is applying the structural testing into larger modules or subsystems, would be too cumbersome because structural testing is applied to the source code, and well, in a unit, of course, we have less code to test than in a subsystem or in the entirety of the system. That's why black box testing is better testing or suitable, more suitable testing type for testing larger portions of the code, which is integration system or acceptance testing. So do you understand why black box testing is based upon input classification and why it is suitable for integration system and acceptance testing? This has two reasons. I told you, because modules are small, they don't fulfill meaningful tasks. They're only responsible for portions of the meaningful tasks that make up the responsibility of a subsystem or system. And the second reason is structural testing or white box testing is not feasible in larger portions of code, such as a subsystem or system, because they of course contain much larger pieces of code, which where structural systems would have too many test cases to be applied. Okay. Uh, well, let's look at the black box testing from a diagrammatical viewpoint. Well, this here is the software product, and uh, the black box testing paradigm considers the software product as a black box. The inputs are coming in and outputs are going out, and the black box testing checks out to see whether the output that the software product provides software product provides is correct or not. If they're not correct, then that means the black box testing found out a problem in the code. Yes, as I said in the beginning of the black box testing, white box testing is a structural testing and black box testing is a functional testing. In the black box testing, internal details of the software code is hidden to the testing team. Here, especially the structure or the source code of the software product is tested. The tests are based upon the structure, based upon the source code of the software product. Structure of the software is examined in detail at the level of program code. Objective to traverse as many paths over the code as considered necessary. So path is the execution path. We will see that in detail in the white box testing chapter in 2 weeks or 3 weeks, I guess. This white box testing is based upon the control flow and data flow. Several forms of coverage, that is the coverage of source code, are possible. That is path coverage, statement coverage, branch coverage, etc. And this is especially suitable for module testing from the obvious reasons I clarified in black box testing. Let me repeat what I told you there. Uh, White box testing is a structural testing paradigm, and since modules or units have less source code, are composed of less source code, are a smaller amount of source code usually, these are feasible to to be tested by white box testing paradigm. Okay. Well, this is this is the control flow of some algorithm. The algorithm starts executing at point B. These are statements. These are simple statements, and these are the decision points, decision statements, such as, for example, an if structure or a case structure, where the control flow may divide into several paths. And this is also for example, this here is a loop, a for loop or a while loop or a repeat loop. And as I said, these are the simple statements, and this is the end of the algorithm. Okay, that brings us to the management of testing. Well, the management of testing starts or consists of several activities. Management of testing starts with the test planning and execution of the tests, evaluation of the tests, documenting these tests, and then reporting them to the necessary staff. Okay, well, if you like, stop here and let's come back at 9:30 and continue thereafter with the management of testing. Okay, I will see you at 9:30. Okay, let's start, if you may. Uh, well, we were talking. Okay, before starting the discussion, please don't hesitate to ask any questions. Okay, if any questions may arise, don't hesitate to ask them. If you don't want to ask in this environment, then please send me an email if you like from our group email, or you can also send me your questions from my uh, own email, private email, however you feel comfortable. Please, but please do ask your questions. Please don't hesitate to ask your questions, especially in this type of environment. I would really like you to ask your questions. Don't hesitate to ask them, okay? Because we have a limited, interactively limited environment. So that may make your understanding of the subject a little harder. So to avoid that problem, to eliminate that problem, uh, please don't hesitate to direct your questions. Don't hesitate to ask them. All right. If you don't want to ask them here, please do ask them through email. All right. But don't leave your questions unanswered, please. All right. Let's now continue uh, with the management of testing. Well, we talked about the different activities of testing. We have to plan them first, and then we have to execute these tests. Then we have to evaluate the results of the tests. Then we have to document the testing process, and finally we have report them to the relevant staff. Okay, here this diagram is a nice diagram that shows each of these activities along with the activities of the software process. Okay, this diagram is also a justification of the validation of software validation, how the software is validated. Um, okay. Well, for example, while preparing the test plans, we make use of the requirements. So we make use of the requirement specification document while we prepare the test plan. Okay, and while we design the tests, that is, while we prepare the test case specification, we use the design specification because each part of the design should be examined, should be validated using a set of test cases. So these test cases are prepared using the design specification document. The next step in the test management is the execution of tests. Well, we prepare using test cases, we code the tests, we prepare the test code, testing programs, okay? And from the coding tests, we get the tests as the output. And using these tests, we execute the tests and we take the bug reports, we receive the bug reports, and using the bug reports, we, in the evaluation portion, we evaluate the test results, and then we prepare the test summary report, what the tests say, how the test results came up, and as a report, we provide this to the relevant staff that will evaluate these reports. This is the testing process. Okay, now let's come to the let's come to the standards about the software test documentation. Here in this portion of this discussion, we will talk about how to prepare test plans. Okay, not how to prepare tests, but how to prepare the test plans. Okay, so according to the IEEE, the test plan is the scope, approach, resource, and schedule of testing activities. Okay, test plan clarifies the scope, the approach, the resources, and the schedule of the testing activities. Well, test design specification, what is this document? This document is the refinements of the test approach and the features to be tested by the design and its associated tests. Okay, a test case specification is a test case identified by the test design specification. So test plan is the scope, approach, resource. Okay, it includes the scope, approach, resources, and schedule of testing activities. Test design specification is the refinements, the extraction of the test approach and the features to be tested by the design and its associated tests. Test case specification is the extraction of a test case from a test design specification, and test procedure specification is the procedure in which or which will be followed during a test. This is the steps for executing a set of test cases, or more generally, the steps used to analyze a software item in order to evaluate a set of features. Okay, this is how IEEE standardizes the software test documentation. Now it continues. The fifth item is test item transmittal report. Okay, what is this? This is the test items being transmitted for testing, including the person responsible for each item, its physical location, and its status. So test item transmittal report is the describes the test items being transmitted for testing, including the person responsible for each item, its physical location, and its status. Test log is a chronological record of relevant details about the execution of tests, okay? That tells us what events have occurred during a test, during the execution of a test. And test incident report, that is also called the bug report. It is any event that occurs during the testing process which requires investigation. So this is extracted from the test log that tells us what is to be paid attention for. Okay, there is some event that occurred during the testing process, and it requires some investigation. It requires some inspection. And finally, test summary report describes the results of the designated activities and evaluations based on these results. Okay, now, well, this here explains us, how a test should be planned, specified design should be test design should be specified, how a test case should be specified, how a test procedure should be specified, how a test item transmittal report should be prepared, how a test log should look like, how a test incident report or bug report, what bug report should contain, and finally, how a test summary report should look like. This documentation standard tells us or describes this. Now, this portion of the document or the lecture tells us how a test plan should look like. All right, how a test plan should look like. Test plan should be composed of, or it should start with an identifier. The test plan identifier should specify the unique identifier assigned to the test plan. Okay. An introduction should be included in the test plan that should summarize the software items and software features to be tested, provides references to the documents relevant for testing. So this introduction summarizes the software items and software features to be tested, what software items are tested in this test, and what features are tested. It should provide references to the documents relevant for testing. So these software items and software features tested, uh, why, by what references to be tested? This should be also included in the introduction. For example, the reference may be the overall project plan, the quality assurance plan, configuration management plan, applicable standards, etc. So whatever we uh, perform this test should be, or according to what document we are performing this test, should be included in the introduction. The third point is test items. The test items identify the items to be tested, including their version revision level. Okay, at what version are these items that are to be tested? Again, this should provide references to the relevant item documentation. It should be a requirement specification document or design specification document or user's guide, operations guide, installation guide, etc. So this one, this one is here. The reference is let's say, is a more comprehensive document. It's either the overall project plan or quality assurance plan. And here we have a more specific reference, like requirement specification document or design specification document, etc. Test items also identify items which are specifically excluded from testing. If there are any items that we exclude from testing, then these should be noted in the test items too. At the fourth point, we list the features to be tested. What features are we testing in this test? It identifies all software features and their combinations to be tested, identifies the test design specification associated with each feature and each combination of features. Okay, at the fifth point, the features that are not to be tested explicitly, that are not to be tested, should be identified explicitly. All features and significant combinations of features which will not be tested and the reasons for not testing them should be identified here. Well, at the sixth, at the sixth point, we should describe the approach of testing. Here, the approach describes the overall approach to testing, the testing activities, techniques applied, the testing of non-functional requirements such as performance and security, the tools used in testing, specify completion criteria, how should the test be ended, for example, error frequency or code coverage, the approach identifies significant constraints, such as testing resource availability and strict deadlines. Okay, these, for example, are relevant for, especially for real-time systems testing. Uh, and it serves for estimating the testing efforts. Okay. The seventh item is about item pass fail criteria. Here you should describe what criteria you should use to be able to say that the system or the module has passed the test or failed the test. Okay, it specifies the criteria to be used to determine whether each test item has passed or failed the test. Suspension criteria or resumption. Okay, this portion, this item should clarify in what conditions you can suspend testing and how to resume testing again. It specifies the criteria used to suspend all or portion of the testing activity on the test items. Well, these may be examples, maybe at the end of the work, okay, I suspended testing because the end of the working day has come, or due to hardware failure, or other external exceptions, etc. And it specifies the testing activities which must be repeated when testing is resumed. Okay, this is also an important thing. In case of resumption, that is, while resuming the test, we have to make sure we specify here which testing activities must be repeated when testing is resumed. Okay, test deliverables identify what should be delivered at the end of the testing. It identifies deliverable documents, typically test design specifications, test case specifications, test procedure specifications, test item transmittal reports, test logs, test incident reports, description of test input data and test output data, description of test tools. So these are mostly documents that we have covered during the test documentation in the previous portion of the discussion here. The standards for test documentation regarding IEEE, we have mentioned all of these deliverables. Okay, testing tasks identify the set of tasks necessary to prepare and perform testing. Description of the main examples may be description of the main phases in the testing process, design of verification mechanisms, plan for maintenance of the testing environment, etc. Okay. And environmental needs, these specify what are the needs for this test. It may be hardware, it may be communications and system software. Software libraries may be a requirement. Test support tools, level of security for the test facilities, drivers and stops to be implemented, office or laboratory space, etc., etc. So these are the all external needs that are required to be able to perform a specific test. 12 is the distribution of responsibilities. This portion identifies the groups of persons responsible for managing, designing, preparing, executing, witnessing, checking, and resolving the testing process. It identifies the groups responsible for providing the test items and the environmental needs at the section 11. Okay, so the groups responsible for providing the test items are here, and environmental needs, these are listed here. Well, staffing and training needs specifies the number of testers by skill level and identifies training portions. What testers and at what levels do we need to perform a specific test? This is specified here. The number of testers, and they're specified by their skill levels, and identify training options for providing necessary skills. Okay, the 14th point in the test plan is about the schedule. This portion, this 14.14, describes the timing of the test. It includes test milestones, those defined in the overall project plan as well as those identified as internal ones in the testing process. It estimates the time required to do each testing task, identifies the temporal dependencies between testing tasks, specifies the schedule over calendar time for each task and milestone. About the temporal dependencies between each testing tasks is like, for example, before performing this task, I'm sorry, before performing this test, what other tests should be performed beforehand? And another temporal dependency is this test is the precondition of what other tests, I'm sorry. So what are the prerequisites of this test? What other tests are the prerequisites of this test? And what is this test a prerequisite of what other tests is this test a prerequisite of? And also it specifies the schedule over the calendar time for each task and milestone. Okay, well, number 15 in the test plan, risks and contingencies. These identify the high risk assumptions of the test plan, lack of skilled personnel, possible technical problems, etc. It specifies the contingencies, that is resolution plans for each risk, like employment of additional testers, increase of night shift, exclusion of some tests of minor importance, etc. So this here also shows us that risks are started to be explicitly considered in the new software process models. And finally, at the 16th item, we write who should approve of this plan. Okay. Now, so much about the test plans. Also, all right, 16 different items should be considered in planning a test, in a test plan. So we have looked at the two main documents. One is the standards for the documentation. This explained the way the tests should be performed, and the test plan, this here explained the details of an entire test. Okay. Now, this here is the specification of a test case. So here we understand how a test case is specified. So the standards, the first document was about the standards of the tests in general. The second document is about how to prepare a test plan, okay, what a test plan should include. And the third, this current document is about how to specify a test case again. Okay. A test case specification identifier, again, it should identify with a document identifier. And this document, since this document is a test case specification, we call it a test case specification identifier. Okay. It should uniquely identify what test case specification that is. At the second, we list the test items. It identifies and briefly describes the test items and features to be exercised by this test case. It supplies the references. It lists the references to the relevant item documentation. Is maybe, okay, these test items to be tested should be originating from the requirement specification document or design specification document or user's guide or operations guide, installation guide, etc. So whatever the reference is, where it comes from, where it stems from, should be also documented in this second point. Well, inputs should be specified. This here, this third point should specifies what inputs are to be fed to the test case, are to be presented to be is to be presented to the test case. Okay, it specifies each input required to execute the test case by value with tolerances. Okay, these input specifications, of course, should be made by value with tolerances or by name. It identifies all appropriate databases, files, terminal messages, memory resident areas, and external values passed by the operating system. Okay, so where it comes from, it should be okay. This input, where do we find it? Where it can be found? Database, files, terminal message, etc. It specifies all required relationships between inputs. For example, timing. All right. We continue with the test case specification document. It also should document the output specifications. What do we expect? It specifies all of the outputs and features. For example, response time required of the test items provides the exact value with tolerances wherever appropriate for each required output or feature. So, well, here, okay, we start with the test case specification identifier. Here we list the items that we will test, including where they originate from. Here we specify the inputs to perform, to execute this test, what input we should feed the system with, what input we should present to the system, and we have to specify this input using where it or including where it comes from, with relationship, also including the relationship between inputs, etc. And at the fourth point, we should identify or specify, I'm sorry, we should specify what output we expect once we feed the system with this input at the third point, what output we should expect from the system. It should specify all outputs and features, for example, response time, required of the test items, provides the exact value with tolerances where appropriate for each required output or feature. Okay. The environmental needs. What should be the environmental needs of this specific test? Here we should provide these. What software configuration is needed? What hardware is needed to execute this test case, as well as other requirements such as especially trained operators or testers. Okay, do we need some specifically trained testers, testing engineers, test engineers for this specific test? Oh, sorry. If there are any, we should also list special procedural requirements. It describes any special constraints on the test procedures which execute this test case, special setups, operator intervention, etc., etc. Here at the seventh point, we should list the intercase dependencies. That is, we should list the identifiers of the test cases which must be executed prior to this test case. Describes the nature of the dependencies. Okay, again, as the temporal dependencies in the previous, okay, as here, the temporal dependencies. Here we have to specify what tests should be done before, what test cases should be performed before this test case is executed. Okay, and we should also, if any, if we can, we should also describe the nature of the dependencies between the test cases. Now, this was the third document, the test case specification document. And the fourth document is the test incident report. So how this is the answer to the question, how should we prepare the bug report? All right. Again, the bug report also starts with an identifier, uniquely identifying what bug report this is. The second is a summary of the bug report. It summarizes the bug incident by identifying the test items involved with version and revision level, and by referencing the relevant documents, test procedure specification, test case specification, test log, etc. So an identifier and a summary of the bug incident. What test items are involved with what revision level, version revision level, and what documents were the reference to that test items. These should be in the second point, in the summary. Okay. Now, this is a very detailed description of bug at the point 3. It provides a description of the incident so as to correct the bug, repeat the incident, or analyze it offline. What inputs what inputs are used? What expected results we had? What actual results came up? What was the date and time? What was the test procedure step? What was the environment, the hardware and software sources or tools? Repeatability, whether the bug repeated or whether the effects of the bug repeated. Did they occur always? Did they occur occasionally or just once? Who were the testers? Who were the other observers? What is the additional information that may help to isolate and correct the cause of the incident? Okay, so other additional descriptions are done in the point J that may help to locate the cause of the problem. For example, the sequence of operational steps or history of user interface commands that lead to the incident. The fourth point is, okay, this is a very detailed description of the bug. Now, impact, how serious is the bug? Priority of solving the incident, correcting the bug. Is it urgent? Should it be paid attention to right away, or should it be done today, for example? Is it a medium impact bug, or is it a low impact bug? Okay, now this is the test summary report. This is the fifth, I guess, 3, 4. This is the fifth document, I think. Test summary report identifier. So it specifies, again, the identifier specifies the unique identifier assigned to this report. A summary follows then. It summarizes the evaluation of the test items, identifies the items tested, including their version, revision level, indicates the environment in which the testing activities took place, supplies references to the documentation of the testing process, test plan, test design specification, test procedure specification, test item transmittal reports, test logs, test incident reports, etc. Variances, okay. This reports any deviations of the test items from their design specification. Okay, if for example, if for example, uh, this test has been defined in the test design specification at some way, and if the test has been performed somewhat deviating from however it is specified, then this variance, this deviation should be absolutely noted, definitely noted in this third point. In what ways was the execution of the test different than it is designed, it is described in the design specification of the test? Okay. Uh, and it should also include the reason for this variance. Okay. And all variances should be reported in this third point. All deviations of the execution of the test from the description should be explained here along with the reasons. Uh, okay, comprehensive assessment. It evaluates the comprehensiveness of the actual testing process against the criteria specified in the test plan. It should identify features or feature combinations which were not sufficiently tested, and it should explain the reasons for omission. Okay, if okay, if the testing process, testing procedure is explained in some way, described in some way in the design specification, in the test plan, but it is not comprehensively executed, then in what ways is it not comprehensively executed? This should be written here, this should be reported here, and the reasons for this omission should also be reported in this portion of the report. Okay, summary of results. It summarizes the success of testing, such as coverage in white box testing, for example. It identifies all resolved and unresolved incidents. Okay, this test should identify also all resolved and unresolved incidents. Evaluation of the test. It provides an overall evaluation of each test item, including its limitations, based upon the test results and the item level pass-fail criteria. Well, at point 7, a summary of activities should take place, should be reported. This portion summarizes the major testing activities, what tests are done, and the major testing events. It further summarizes the resource consumption, what resources are used, total staffing level, such as total staffing level, total person hours, total machine time, total elapsed time used for each of the major testing activities, etc. And finally, this last point should specify the persons who must approve of this report and the whole testing phase. Okay. Let's look at the inspection checklist for the test plans. Here we should ask we should ask ourselves these questions if we have complete if we have covered the test plan in a satisfactory manner. Have all materials required for a test plan inspection been received? Are all materials in the proper physical format? Have all test plan standards been followed? Has the testing environment been completely specified? Have all resources been considered, both human and hardware software? So these questions should clarify how well we performed, we executed, or we followed the test plan. Have all testing dependencies been addressed, driver function, hardware, etc.? Is the test plan complete? That is to say, does it verify all of the requirements? For unit testing, does the plan test all functional and structural variations from the high-level and detailed design? Is each script detailed and specific enough to provide the basis for test case generation? Are all test entrance and exit criteria sufficient and realistic? Are invalid as well as valid input conditions tested? Have all pass-fail criteria been defined? Well, if you can answer these questions comfortably, then that means you have prepared a very good test plan and you can execute them comfortably. Okay, the questions go on. Does the test plan for the test plan, does the test plan outline the levels of acceptability for pass, fail, and exit criteria? For example, defect tolerance. Have all suspension criteria and resumption requirements been identified? Are all items excluded from testing documented as such as necessary? Have all test deliverables been defined? Will software development changes invalidate the plan relevant for unit test plans only? Okay, this doesn't apply to integration or system test plans. Is the intent of the test plan to show the presence of failures and not merely the absence of failures? Because this doesn't apply. Is the test plan complete, correct, and unambiguous? Are there any problems, conflicts, amalgamations in the test plan or not? This 18th question inspects for this. Are there holes in the plan? Is there overlap in the plan? Are there any missing places for some tests in the plan? Okay. Or there are overlaps in the plan, redundant portions of the plan. Does the test plan offer a measure of test completeness and test reliability to be solved? Are the test strategy and philosophy feasible? So these are some questions that you may ask yourself to inspect to determine whether your test plan is complete, if you feel comfortable with your test plan. About the inspection checklist for test cases, for each test case, what questions can you ask yourselves to study whether your test cases are complete and consistent? Have all materials required for a test case inspection been received? Again, the very same question as the test plans. Are all materials in the proper physical format? Well, these two make sure that enough material has been collected and the environment where the test case or the test in general is executed is in shape. Have all test case standards been followed? Are the functional variations exercised by each test case required by the test plan? Are the functional variations exercised? They should be taken into consideration by each test case required by the test plans. Are the functional variations exercised by each test case clearly documented in the test case description? Well, this is again for the unit test case documents only. Does each test case include a complete description of the expected input and output or result? Have all testing execution procedures being defined and documented? Have all testing dependencies been addressed? Driver function, hardware, etc. So, and finally, do the test cases accurately implement the test plan? Do the test cases cover what is expected of the test? So these are some questions that compose the inspection checklist for test cases. Okay, so this is taken from a different reference than your textbook. This is from Myers, The Art of Software Testing. It is from 1978. It's an old document, but it still applies to up-to-date testing engineering. Okay, well, do you have any questions? Do you have any points that you don't understand? If you have any questions, please let me know from the chat panel here right now. Or as I said, you can let me know about any problems um, through my private email or from the group email if you wanna let your friends know about your questions too. Okay. All right, I don't see any questions from the chat panel, so please let me know if you have any from my email. You can communicate with me anytime through my email. You can write your TA to Berna. Please, well, I have, okay. Fırat, I don't need to take attendance because I already have all of your entrances, times that you have attended in my file automatically. Okay, I don't need to take an explicit attendance because I have all your information, whether or not you are attended, how long you have attended, how many times you exited and then came back. All this information I have automatically in this meeting session, so I don't need to. Okay, please continue with your projects, because the projects are, as I wrote to you from the group email, the projects are extremely important and they're very valuable, especially in that kind of learning environment, because our well, at least the exams have been delayed now, so that makes the evaluation of the projects much more valuable. So please give significant effort to completing your projects. Okay, if you have no other questions, I'm going to end this session. Do you have any questions? One more time. Okay, I will see you then next week on Tuesday at 11:30. Goodbye now.